Okay, so hello everyone, welcome. Can you hear me?
Yes, yes.
Okay, thank you. Just be waiting 1 minute and we start.
Brother Nizam, just the scripts are becoming, too many. So before, if you starting, if you can help us in how to make a repository different
Okay, okay, understand.
or folders for it to
Okay,
keep the scripts
okay,
or the codes in. Yeah, thank you.
okay. So we can easily save all of code in our asset under the script tab. The script tab we can easily create it the folder in this under this folder. We can easily put all of the script which you save. Okay, I'll show you that how we can easily do it. Okay, so let's go. We'll start our today's session. So let me share my screen. Can you see my screen?
Yes.
Okay, so basically today is our fourth number class, and mainly today's session I try to describe about that how to remove the cloud and haze from the satellite imagery. It can be Landsat or Sentinel. Both of satellite imagery, how we can easily remove the different types of cloud and get the very neat and clean imagery in Google Earth Engine. We also talk about that DEM data, mainly digital elevation model data, how we can easily use the DEM data and create the different types of terrain profile, such as hillshade map, then aspect map, slope map, or hillshade view map. So this type of map, how we can easily create using Google Earth Engine. We also try to discuss about that. And we also talk about that land surface temperature monitoring, how we can easily monitor the LST. So previous class I discussed about the MODIS satellite imagery, but in this for today's session I will try to explain about that how we can really use the Landsat satellite imagery and create the LST map, as well as how we can really monitor the urban heat island or urban thermal fields variance index, how we can really monitor. We also talk about that, as well as how to make time series chart, okay, for LST after creating the Landsat image, or temporal change of LST after creating the Landsat satellite image. So let's go. We can discuss one by one all of things. So first of all, I want to work for, suppose, Landsat imagery, and I want to work for the specific boundary or city's boundary. I want to monitor the LST. So first of all, simply import your shape file. Suppose this area you want to make the study area. So just I had already imported the shape file. So now I want to work with this, and then I want to create the LST map or land surface temperature map for my study. Suppose I randomly take it. Suppose this is my study area. This study area I already imported my asset tab. So now I want to use it and then make the LST or land surface temperature. So simply import. So now it imported. Then you can put the variable name. I put the name, suppose ROI, or you can put any variable name. And further, just I want to display my study area. Just add the layer of your boundary shape file, ROI. And then also focus on the center of this boundary shape file. I put the zoom level, suppose 10, and click the one. So this is my study area. Suppose for this study area, I want to monitor the LST or land surface temperature, as well as also make the time series chart, as well as I also want to make, suppose, urban heat island or also urban thermal hill variance index. How do? So in this case, I want to use the Landsat imagery. So first of all, you need to import this Landsat imagery. So just import it. So go to the data catalog. Here you can see the Landsat imagery. Suppose I want to use for the Landsat 8. And basically for LST monitoring, we have to use the surface reflectance satellite image to monitor the LST. So this is a surface reflectance satellite imagery. So this image I simply import in my code editor. So simply copy this unique ID. Just simply copy. And then paste on your code editor. So just simply paste it. Then give a variable name. You can put any name as a variable. I put the name, suppose, image. Okay. So now this is my image collection. So now this image collection, I just need to filter for my study area for the specific time period or a specific cloud cover level. So we already know about that, how we can easily filtering the satellite imagery. So just I simply write the code. First of all, simply use at that dot filter bounds function. So it intersecting with your study area. This is ROI. ROI is stored in my shapefile boundary. Then we have to use at the filter metadata. Suppose in this case, I choose all of images which is less than 1% cloud cover. I consider less than 1, and put the time period. Suppose I put the filter date, and I will choose, suppose, year of 2023, 1st January from year of 2023, December 31. So this is my time period. So just I simply filtering my image collection for my study area, then cloud cover level, and also a specific time period. Suppose I choose the year of 2023. You can choose any specific summer season, rainy season, or any time period. So now let's check how much images are available in this collection after filtering. Just simply print and use at the image and use at the size function. So now it computing after filtering image collection. We find out the total 25 images for my study area. Okay? And this 25 images is the capture for the different time period of the year of 2023. So now I want to use the median composite and create the image. So just use here the dot median, and then just click with my study area, which is ROI. And further, simply display the image. Just map.add layer and call the image and click the run. So now we got our satellite imagery. So I just use this satellite imagery, and further we just make the LST map. So we try to add the visualization. So for that, just click on here. And I said, suppose red, then green, and blue. Stressing of 98%. And now we got this type of imagery for this study area. Just I simply import and further copy this variable name and paste after the object. Just it set the visualization parameter for this image. Just paste and I put the it's a suppose imagery. Okay. So now we got our imagery for Landsat 8 surface reflectance satellite imagery in year of 2023 for my study area. So now I want to use this imagery and make the LST. Okay. So first of all, if you want to check the normal algorithm, suppose I simply search here LST monitoring using Landsat 8, we can see that a lot of research paper is already published. They are used at the Landsat 8, and further they are compute the LST. Okay. Suppose I just simply open this paper. So this is the Landsat 8 for estimation of land surface temperature in the Patna city, eastern Algeria. So in this time here you can see they are already provide this type of algorithm or flow chart. So in this case here you can see this is the algorithm they are using here. So basically they are using the Landsat 8 satellite imagery. Further you can see here they are calculated the NDVI using the near infrared band and red band, and they also take the thermal infrared band, which is band 10. Band 10 is called also thermal infrared band or brightness temperature. Okay. And they are also calculate the vegetation proportion or fractional vegetation, as well as also they calculate about that brightness surface emissivity from here. They also calculate about that. Okay, there you can see we can get this type of follow chart. So in this time, just I try to follow this type of algorithm, as well as even to check the other paper also. Suppose here you can see some kind of paper, we can easily get it. So there's a lot of paper is already published. They are used at the Landsat imagery and then calculate the LST or land surface temperature. Okay. So let's we try to suppose first of all we need to calculate the NDVI. So this is our first step for LST monitoring using Landsat imagery. So I already imported my satellite imagery. So this is my satellite imagery. So now I just use this satellite imagery and then make the NDVI map. Okay. So just we try to add the NDVI. Just take a variable, suppose NDVI, and we already know about that how we can easily calculate the NDVI. So just I call the image and use at the normalized difference function between the two band, near infrared band and red band. Mainly SR B5 near infrared and then SR B4 in near infrared band and red band. So now it creates the NDVI. Just I simply add the layer of this NDVI map. So map.add layer and call this NDVI and click the run. So now it created the NDVI map. So this is the first step for creating the LST using Landsat imagery. So first of all, we create the NDVI map. And if you want, you can also add the color. Suppose just put here the color of the NDVI map. I just use the color, suppose -1 and put at the max, suppose +1 and put the color plated. So just I make the list. Suppose I put at that, suppose put at that, suppose at the white or any color you can simply put in here or green. Click the and also put the layer name. Suppose it's the layer of NDVI. So now we create the NDVI map, and further after creating the NDVI map, we need to calculate the vegetation proportion or fractional vegetation. So you can easily get the equation from here. Suppose I simply open this paper, and this is the same equation for all time we have to use for vegetation proportion or fractional vegetation for estimating for vegetation fraction. So, so here you can see this is the vegetation proportion, okay, and this is the formula, and I can see about the citation about this formula. So basically this formula is that NDVI minus NDVI minimum value divided by NDVI max value minus NDVI minimum value and then power 2. Okay, so this is the formula. When I calculate this formula, then I can easily get the proportion vegetation or vegetation proportion I calculate or fractional vegetation I calculate. Just use this formula. So in this formula, I need the two value, NDVI minimum value and NDVI maximum value. Okay, then I can easily calculate this type of formula. So let's go try to calculate the NDVI minimum value and NDVI maximum value for our study area. So this is our NDVI map. We can get this type of map. So now from this NDVI map, we try to calculate.
Mizan?
Yeah, please.
Yeah, Mizan, this is deduced from 25 images for the study area in 1 year 2023.
Yeah, in this time we take all of imagery.
This is NDVI.
Yeah,
Yeah.
NDVI is
This is NDVI prepared from 25 images.
Yes. Because in this time you can say I just call the images. So it is stored all of 25 images, median pixel value or middle pixel value, and create this composite. Okay, so now we can got this type of NDVI map. So from this NDVI map, we need to calculate the NDVI mean value, and also need to calculate NDVI max value. So these two value we need to calculate because this is my equation. This equation, when I calculate, I need the two value, NDVI minimum value and NDVI maximum value. Then I can easily calculate this equation. So let's go try to calculate the NDVI mean value. Just take a variable, suppose mean, and I have to calculate the NDVI mean value, and I already calculate the NDVI. So this is my NDVI map. This variable is stored in this map. So from this map, I want to calculate the NDVI. So I simply copy the NDVI and then use it. Okay, just simply copy this variable NDVI and paste here, and then use the function reduce region. Okay, so basically this reduce region function calculate the statistical value. Okay, in this case, I want to calculate the mean or minimum value of NDVI from this NDVI map. I want to calculate the minimum pixel of NDVI value for my study area. So it's one kind of a statistical value. So that's why you have to use the reduce region function. So then further just put all of argument one by one. Just make the dictionary. So just I make the dictionary, just put here the curly bracket start and also curly bracket in. Okay, just curly bracket in. And for the reducer mainly in this take, I want to calculate the minimum pixel of NDVI. So for that use here EE dot reducer dot min. Okay, this function calculate the minimum value of NDVI. Geometry, it's your shapefile variable name, which is ROI. Okay. Scale is the resolution of your satellite imagery. For Landsat, 30-meter resolution. And others not need, remove that. And now further, if I just print this min, click and click the run. So now it's computing the minimum NDVI value for my study area. So we find out this type of result. Here you can see it show the negative 0.1. This is the NDVI value for negative. We find out that minimum NDVI value for this study area. But in this case, here you can see this result show as a dictionary. Dictionary means that it have keyword and key value. Okay. But in this case, I just need only for this value. Only for this value I need. Okay, I don't need for this dictionary. So you can see the dictionary. In this dictionary, we find out the keyword and key value. But for my equation, for my equation, I just need only for the number, only for the value I need it. So for that, I simply use a function in here. I just put the values function. This values function just extract the value, just extract the value. So put here the values and further put here the get and then put here the 0. 0 means that first item. So in this dictionary, it has only for the one item, and first item refers to the 0 in JavaScript programming, 0 indicating the first item. So just I extract the values from this first item, basically first dictionary. So now if I run the code here, you can see now it show only for this value. You can see computed object, and just we can get the value without dictionary. So in this time it just show only for the value. But this value I want to use as a number, because in my equation I put the it's a number, minimum NDVI value, it's one kind of number. So for that I have to convert it into number. So in this case, when I run the code, you can see it show the result as a computed object. Okay, but this computed object I want to convert into number, because for the next time I want to use it as a number. So for that, just use here a function p dot number. So now this computed object we consider or convert into number, because for the next time I also need to use it as a number. So if I run the code in this time, you can see it show the number computing. Okay, so now this number I can easily use, or this variable mean this variable now stored the number. So now further I can easily use this variable for any equation as a number and computed the equation of fractional vegetation. Okay, so we can got this minimum value of NDVI and just apply the same process for maximum. Just I simply copy the same code and then paste here, and I put the variable name. Suppose I put the name is that max, and then just simply change it the function max, and then print the maximum value max. So click the run. So now we can got the maximum value of NDVI. Okay, so here you can find out that this is the minimum value of NDVI and this is the maximum value of NDVI. Okay, so now I can easily apply this equation, NDVI minus NDVI mean divided by NDVI max minus NDVI mean power. So now I can easily apply this formula, and further we can calculate it, the fractional vegetation. So let's try to calculate the fractional vegetation or proportional vegetation. It's the same term. So just we try to calculate. So this is our second step to fractional vegetation. We calculate it. And for the fractional vegetation, I need the minimum value and maximum value. So that's why I can just calculate or computing the minimum value and maximum value. Okay. And further, just take a variable. Suppose I put the variable FV or fractional vegetation. You can put any variable name. And I have to calculate this equation. Okay. This equation you can calculate it different way, because previous class I discussed about that we can easily use the Drake equation or expression. So different way we can just follow and we can easily calculate this type of equation. Suppose I want to follow the Drake equation. Just I simply Drake equation. Just I call the NDVI. This NDVI subtract with minimum value. So just call the mean variable, and then it divide with maximum value, subtract with minimum value. So just call the max, it subtract with min. Okay, and then we have to set the power 2 and full equation. So for that I simply start the parenthesis and also close this parenthesis, and then use here the power function, POW. It means the power. And power 2 is a number. Okay? So when you define any number or when you construct any number, then we have to use a function EE.number. So just put here EE.number and then put the power 2. Okay. So this is the equation. You simply calculate NDVI minus minimum value of NDVI divided by maximum value of NDVI minus minimum value of NDVI, and then power 2. Okay. So now we can calculate.
Mijan, this
yeah, please.
yeah, this NDVI that we collected in the beginning, this is the median NDVI. Am I right?
It's it created
The
from
one,
median satellite imagery.
yeah, median in the beginning when we calculated. So it was for the median image.
Yeah, it was median image. Yeah, median pixel image.
So does it need to be converted to number, or is it okay? Like we converted the minimum and the maximum to number.
Yes. So from this minimum and maximum value come from this NDVI map. Okay. And this NDVI map is generated from this imagery. And this image is generated from 25 images middle pixel value and create this composite. Okay. So further, we are just put this type of equation, power 2, and we are just simply rename it. Suppose I put this rename. I put the rename as it's a suppose FV or fractional vegetation. And then further just simply display the layer, map.add layer, and call the FV and click run. So now it added the another layer for fractional vegetation or proportion vegetation. Okay. So now we got this type of result here. You can see it show the grayscale color. If you want, you can also add the color, so you can easily get it the high vegetation for this type of region. Okay. Or white color, this type of white color. I'm thinking about that high fractional vegetation. Or if you want, you can also in stressing. Suppose just I simply stressing, then you also get that more better view for this layer. Suppose I put here the distressing and further suppose put the apply. So now you got this type of result. And further, if you want to also add the color plated, or I just keep the same, just put the import and then copy this variable name, copy, and paste, and then further I put the it's a suppose FB or fractional vegetation. I put the layer name. So now we got this two layer. One layer is for NDVI, another layer is for fractional vegetation or proportion vegetation. Okay, so this is the second step. Further, we are just call the thermal infrared band and then further calculate the surface emissivity. So for that, here you can see in this satellite imagery, they already have this band. This band name is that STB10. Okay, so this is the band. So this is the surface temperature. It also called the brightness temperature. This unit is the Kelvin. Okay, it also called the thermal band. Okay, so in this time we are just use this band, and further we make the thermal map using this band, and then this band we also useful for make the surface emissivity. So let's go try to calculate this thermal infrared band. So for that, I simply copy this band name from here, and then take a variable name. I put the variable name, suppose thermal. Okay. And this thermal band I call from my images. So I already take this variable name image. Basically, this variable is stored my satellite imagery. So this satellite imagery, it is stored this satellite imagery. And from this satellite imagery, I just call the thermal infrared band. Just use here the select function and call this thermal infrared band, which is STB10. Right? And this band we also need to reproject it, because further we also calculate the surface emissivity. So if I don't reproject it, this escape pixel value, then we not get the proper emissivity value. So that's why we also need to reproject it. And how we can reproject it? They already provide the scale value and also provide the offset value. So this scale value is simply multiply and add with offset value. Simply copy this scale value. This scale value is simply multiply and further add with offset value. Offset value you can see it also already provide. So simply copy and then paste here. So now it reprojected this pixel value. And now if you want, you can also add the thermal infrared band. So just use their map dot add layer and call the thermal. So now it also added that thermal or brightness temperature map. You can get it from this. Okay, it look like type of map. If you want, you can also add the color or spacing. Just simply click on here and then spacing of 98%. Further apply. So now you got this type of thermal infrared band like that. Just a simply import and then copy this selection parameter and paste after this object. Okay. And put it, it's a thermal or thermal layer. So now it's also okay for this thermal. So now using this thermal, we are just surface reflectance is available, but top of atmosphere is not available. Okay. So basically, you can see this the data set. It's a surface reflectance. It's available. The surface reflectance, but surface top of atmosphere, it's not available for the thermal band. So that's why when you want to make the LST map, then we have to use the surface reflectance satellite image or SR. You can see this type of band. Look at the SR. SR means that surface reflectance. Okay. Okay, so now we are just calculating the surface emissivity. Suppose here you can see, this is the paper, and here you can see there type of equation. So surface emissivity can be calculated using this equation, which is here you can see 0.004 multiply with fraction vegetation plus 0.986. Okay, so this is the equation. Okay, here you can see PV is the proportion of vegetation. Okay, and proportion of vegetation you can get. We already calculate this equation and calculate the proportion vegetation or fractional vegetation. We already calculated. So now just we simply apply this equation and calculate the surface emissivity. Okay. So for doing these things, we are just we calculate this equation. So just take a variable. So in this equation here, you can see we got this type of number. We got this type of number 0.004 and also 0.986. So it's one kind of constant value. So this equation 0.004 and 0.986, it's one kind of constant value. So this constant value, I simply store it in a variable. Okay. Suppose I just take the variable and store it this type of value. Further, I can simply use this value in my equation. So let's go try to store it this value in my in a variable. I take the variable name, suppose A, and I put the EE dot number because it's a number. So just I simply put the number, suppose 0.004. Okay, And another number, just take the variable b, dot number, and I put the suppose 0.98, 0.986. Okay, so these two value I simply store it the a and b, and further I simply apply this equation. I take a variable, suppose em or surface emissivity, just em, I take the variable, and I call the fractional vegetation. I already calculate the fractional vegetation. You can see fp, it already calculated. I simply copy it and further paste here, and then these things multiply with 0.004, which is stored in the a. So I simply copy the a and paste here, and then add with 0.986. I simply call the b. So now we can calculate the surface emissivity, and I rename it. Suppose I just put the rename it. I put the name, suppose EM, or you can put any name, because further we also need to use this type of name. So just I simply rename type of layer name, and then further I want to display the surface emissivity layer. So map.add layer and call the EM. Click the run. So now it also added the surface emissivity layer in our map. It look like that, this type of white color. So when I tracing, then you also get the more better result. Just click on here. And so the tracing was 98%. And further, if you want, you can also add the color. Suppose I put this type of color. Suppose I put this type of color. Then suppose then yellow, and high value I need to show suppose this type of red color, or any color combination you can choose. So then I simply apply. So now it also added the colorful surface emissivity map, and here you find out that high value of emissivity, it shows a red color. So you can get this type of map for that. So this type of red color indicating about the high surface emissivity value. Just a simply import, and then copy this variable name for visualization parameter. You copy and paste after the layer name, object name, just paste here, and then put here the EM, or I put the layer name, suppose you can put any name as the layer name. So now we also calculate the another layer for surface emissivity. Okay. So surface emissivity, thermal infrared band, then fractional vegetation, NDVI, all of things we calculated. Okay. So now further we are just calculate for LST. So now I talk about the LST formula. So here you can see this is the LST formula. So here you can see this the LST formula equal to TB. TB mainly thermal or brightness temperature. Okay, TB mainly brightness temperature or thermal infrared band. We already calculated the TB, or thermal band we already calculated, and this unit is the Kelvin. Okay, you can see Kelvin. Okay, and we also already calculated about that this type of thermal infrared band, and this unit is also Kelvin. We already calculated these things, and further also you can see about that lambda. We can get this type of lambda. So lambda value is the wavelength of emitted radiance, so it's a constant value. So 11.5 micrometer, and also you can see rho value. So it's also constant value. So 1.438 10 inverse 2. Okay, and surface emissivity, we already calculated the surface emissivity. This is the log or ln surface emissivity. We already calculated. And further you can see it subtract this value 273.15. So basically it subtract because I need to convert Kelvin to degree Celsius. Okay, so when I subtract this value, then we can get the result in degree Celsius result. Okay, so now we try to compute this equation and further take. Yes, please.
This equation from this paper, is the same that we see it in that paper with the flow chart or something like that. It's the same equation or different equation.
Okay, we have to follow the same for any other region because this type of value is the constant. Suppose here you can see this proportion of vegetation or this type of value is the constant. Okay, so it's we have to use the same. Also, you can see some other paper. Suppose here you can see this is another paper. So in this paper here you can see they are also used for another equation. So here you can see 0.96, 0.8. Okay, and this equation is providing this type of paper. Also, there put the citation. You can see. So basically, surface emissivity they can calculate from the town or natural surface. For the town, they are use this type of equation, and for the natural, they are use this type of equation. Okay. So we have to when you write the paper, then you try to check some reference because they are already create this type of equation, and they put this type of citation, and then also use it this type of equation and make the LST map.
Okay, thank you.
So now we try to complete.
Mizan, just I have a question.
Yeah,
Then one is the natural and the other is the town. So then we will get the what is called the average of both.
So in this case, we try to calculate it the average of both. So in this time, we are just following this paper because in this paper they are mentioned calculate the average of the both natural and town. They are combined. But when you want to work only for the town, then you can also apply this formula only for natural. No problem. So let's go try to calculate for LST. Right. So for the LST, just I take a variable. Suppose I put the variable name is that I put the variable name suppose LST. And then we are just call the